Our final topic this semester is about firearms, tool marks, and impressions. Firearms analysis is what we're going to start out with. Different things you can find out from analyzing firearms. Number one, link a bullet to a firearm. Number two, link a cartridge to a firearm. Determine firing distance, and you can restore serial numbers. Please notice that you cannot link a bullet to a cartridge. Hang on just a second. You cannot link a bullet to a cartridge. You can't ever tell that this bullet was paired with this cartridge prior to a weapon being fired. The basis for all of this is that structural variations and irregularities by wearing down or damage to a gun, to a tool, or a tire track can individualize those different firearms, those different tool marks, those different tires. So let's first talk about weapons, guns. The inner surface of a barrel leaves markings on a bullet passing through it. And these markings are specific to each gun. They're unique. The gun barrel is produced by drilling through a solid bar of steel. The drill it hollows out the center of it, and these microscopic drill marks that are left on the inside of the barrel are unique to each barrel. They're irregular. Making a gun barrel also requires creating spiral grooves. That step is known as rifling. The surfaces between the grooves are called lands. The lands are what come into contact with the bullet as it leaves the barrel of the gun. These grooves cause a fired bullet to spin, and that increases the accuracy, the trueness of the shot. Some terminology. Caliber of a gun is the diameter of the gun barrel. We have class characteristics of a weapons barrel, and they're consistent for a manufacturer. Each firearm from a specific manufacturer will have the same number of lands and grooves and the same approximate width and direction of twist of that particular bore of the barrel. You can see what lands and grooves look like, and then also an explanation of the caliber of the firearm as well. So this is the diameter, that's the caliber of the firearm, and it's between the lands that the diameter is calculated. These are the grooves here, and they're spiraled through the barrel of the gun, which again causes the bullet to spin. That rotational velocity helps keep the bullet on path. Striations, or fine lines, are scratch marks made from the metal against metal contact as a bullet moves through the barrel. And these form the individual characteristics of that particular firearm. And these are what are compared, what you see here, these stripes are the striation patterns. No two rifled barrels, even those manufactured one right after the other, will have identical striation markings. The numbers of lands and grooves and the direction of twist are class characteristics from a manufacturer, as I discussed before, but after that, it's individual. Differences in class characteristics are a lucky break. They serve to eliminate the possibility that both bullets traveled through the same barrel. The tool that is most important for firearms analysis is called the comparison microscope. The lands and grooves of the test and evidence bullet have to have identical widths, but then these striations, these scratches along the bullet's edge have to coincide. They have to match up as well. Problems can arise over time comparing bullets if grit and rust have built up on them, if they're lying outside exposed to the elements, if the bullet hits a hard surface and kind of smashes up on impact or distorts on impact, and then change in striations over many, many years due to wear and tear. Those can all cause problems with bullet analysis. Here's some pictures of handguns. These are handguns. Obviously, they can be held with one hand. Semi-automatics are here. This is a revolver. It's called that because the chamber here turns and revolves, exposing one bullet at a time. If we switch gears to shotguns, a shotgun has a smooth barrel. So shotguns fire small pellets that don't have characteristic markings or striation patterns that you can trace back to a weapon because that barrel is smooth. The diameter of the shotgun barrel is expressed by the term gauge, and this works opposite of diameter of a gun barrel. A shotgun barrel, the higher the gauge number, the smaller the barrel's diameter. What is the process that a firearm goes through in order for a weapon to go off? So first the person pulls a trigger. Pulling the trigger releases the weapon's firing pin. That firing pin strikes a pressure-sensitive chemical called a primer, and that's at the back of the cartridge. The cartridge is loaded with gunpowder. The primer lights, it ignites the gunpowder. As the gunpowder burns, that's a combustion reaction, so carbon dioxide, gas, and water vapor are produced. These gases expand as that combustion reaction of the burning gunpowder proceeds, and that pressure pushes the bullet forward through the barrel, pushes the empty cartridge case where the bullet was originally placed, or shell, back with equal force against the breech block, which is the back of the gun. The shell, or the cartridge, gets markings from its contact with other metal surfaces of the weapon's firing and loading mechanism. So the firing pin, the breech block, if the firearm has automatic ejector or extractor mechanisms for the cartridges, and then the magazine that the cartridges are loaded into. The firing pin, breech block, and ejector and extractor mechanisms give a distinctive signature. So the striation patterns can also be analyzed in the cartridge here. So what you see there, you can see, can't from here, but under microscope you'd be able to see striation patterns here. And you also see the firing pin and point of impact here, and that's going to be unique for different firearms. NIBIN, or the National Integrated Ballistics Information Network, is databases and files of bullets and cartridge casings from crime scenes, test fires from retrieved firearms, and these can help link a specific weapon to multiple crimes. One division of NIBIN, called IBIS, is an automated screening tool for bullets and cartridges. So these are screening tools, but then the final match is made by a forensic scientist using that comparison microscope. When a firearm is discharged, unburned and partially burned gunpowder and smoke are propelled out of the barrel in front of the along with the bullet towards the target, so out the front of the barrel. If this weapon is fired at close range, gunpowder residue can be deposited onto the target and firing distance can be determined. If we're at point blank range, you'll see a star-shaped tear pattern around the bullet hole entrance, whatever it enters into, surrounded by a rim of a smokeless deposit of vaporous lead. From 12 to 18 inches, you see a halo of smoke deposited around a bullet hole. Up to between 25 and 36 inches, you might see scattered specks of unburned and partially burned powder grains. After 3 feet, there won't be any powder residue on the target, you might see a dark ring around the hole known as a bullet wipe. When garments or other evidence are retrieved, the surfaces are examined microscopically for gun residue. Chemical tests such as the Grice test or also infrared photography. Remember that when in doubt, choose infrared. Infrared photography may be needed to detect gunpowder residues that are not visible. The firing distances involving shotguns can be related to test firing. The muzzle to target distances can be established by measuring the spread of the discharged shot. Those are the little pellets. Gunpowder and primer residues are also blown back towards the shooter. GSR, gunshot residue, GSR, is found on the firing hand of the shooter and can help determine if an individual has fired a weapon. It's sort of common sense, but it's more likely to be found the sooner the analysis can be made. Otherwise, you run the risk of having the person wash their hands or just wear off over time. Gunpowder residue contains nitrates, and nitrates are found in a lot of different other substances. So just a nitrate test or just a test for nitrates will give you some false positives. Nitrates are also found in urine, cosmetics, tobacco, and fertilizer. So these can someone could be working with any or all of these items and come up with a positive nitrate test. So really what needs to be tested for is powder residue and primer residue, which mainly contains lead, but there are other elements that are found as well. Serial numbers can be restored through chemical etching with acid. Since the metal is thinner beneath the original numbers because the number was filed away, the numbers will dissolve faster than the surrounding metal because the metal is thinner where those numbers were stamped in. When we're collecting firearm evidence, it needs to be collected by holding by the edge of the trigger guard, or by the checkered portions of the grip, so no evidence is destroyed. The discharge of a weapon is a really smart idea. Emptied. The weapon should be emptied before it is sent to the laboratory. A weapon found in water should be taken to the lab and a sample of that same water. Bullets recovered at the crime scene are initialed either on the base or the nose of the bullet, so either the front or the back of the bullet, because you don't want to mess with the striation markings on the side. That's your evidence. The bullet has to be protected by wrapping it in tissue paper before placing it in a pillbox or envelope. And finally, tool marks. Tool marks are any impression, a cut, a gouge, or an abrasion caused by a tool coming into contact with another object. A careful examination can give you some class characteristics like the size and the shape of the tool. And then any imperfections there are what give you the individualized characteristics. And the shape and pattern of those imperfections and damage and wear will give further modifications. Again, the comparison microscope is super important to compare crime scene tool marks with test impressions made with the suspect tool. Those crime scene tool mark impressions are casted unless the entire object or part of the object bearing the tool mark can be taken back to the laboratory. Impressions also can include shoe marks, tire marks, or fabric impressions. Before any of them are moved, just like we've been saying all along this semester, they have to be photographed with some sort of a scale to show all the details of that particular impression. Again, if it's readily removed from the crime scene, like it's on glass, paper, or floor tile, the whole piece of evidence is transported to the laboratory intact. If it can't be submitted to the laboratory. It's going to be preserved in a manner similar to lifting a fingerprint. If there are class characteristics we're looking for, for a shoe, it's brand, color, style, and size. Individualizing characteristics can include wear patterns due to the physical stature of the person, cuts, slices, or other damage. When shoe and tire marks are impressed into soft earth or mud at the crime scene, that's when we do photography and then casting of that mark. If there's bloody footwear impressions that are faint or tracked through blood leaving a trail of bloody impressions, chemical enhancement through luminol can visualize latent or nearly invisible blood impressions.